Alright, so this is part 2 of our Mendel notes. What we're going to do is we're going to go through the process of predicting the offspring outcomes by using a Punnett square. And Punnett squares, again, are predictions. They do not tell us what the actual results are. They give us a prediction. So you've talked about probability before in your classes. Okay, so for example, if you flip a coin 3 times, what is the chance it will be heads every time? Okay, first we need to think, well, the chances are two possibilities. I have heads and I have tails. The chance that I get heads would be 1 over 2, okay? It's one chance out of two possibilities. But then I'm going to multiply those chances times each other because I'm saying I'm going to get heads 3 times in a row. So when I look at that multiplication, that gives me 1/8, which is roughly about 12.5%. Okay, if you did an actual flipping of pennies, would you always get 3 heads in a row? Well, probably not. Would it happen 12.5% of the time? Probably not exactly either. Remember, a probability just makes a prediction about the outcomes of things. So we can predict the likelihood of genetic crosses producing certain outcomes in offspring. Okay, for example, we're going to use a Punnett square here and we're going to diagram 2 plants that are heterozygous tall. Okay, so what I'm going to demonstrate here, this is the format that I want you to use when you set up your Punnett squares. Okay, so we're on Roman numeral 2, letter A. So first we want to identify the individuals in our P generation. The 2 plants that are heterozygous tall, those are our parents. So, you can choose one to be the male and one can be the female. We also need to identify sort of like a little legend over here of how we're going to discern the alleles. So let's say we're going to use big T for the tall allele. Okay, and we will use a little t for the short allele. All right, both parents are heterozygous tall. We learned in the previous video there, heterozygous means they have one of each allele. Remember, they're going to still show dominance because as long as that dominant allele is present here, it's going to cover up the expression of the recessive one. Since both parents are the same, their genotypes are going to look the same. Okay, now we're going to do the cross. You want to set up your Punnett square, give yourself enough room, and you're going to need 4 boxes. Okay, when we take this gene and we split it up into its possible gametes, we're going to have a big T and a little t here, and we're going to have a big T and a little t here. So just pick one parent to go down the side here, the other parent will go across the top. It does not matter whether it's male or female. And then you're just going to simply do cross multiplication, okay? So we have a big T coming in together, this box and this box. Over here we'll have a big T and a little t. Over here it will also be big T, little t. It's just a common procedure to always put the dominant allele first. And then we will have a little t, little t. Okay, so that's how you fill in the Punnett square. So what these 4 boxes represent are the 4 possible genotypes that the offspring could have. Okay, now we're going to see what the percentage chances are. So the expected genotype and phenotype percentages. I'm going to do genotype right here. Okay, there are 3 different genotypes. We have a big T, we have a big T, little t, and we have a little t, little t. Okay. Of the 4 possibilities, only 1 out of the 4, or you could say 25% chance of being big T. Out of the 4 here, we have 2 of the 4, or 50% chance of having that genotype. And for the last one, it would be 1/4 or 50% chance. Okay? So that's how we find genotype. Remember, the genotype is just looking at the probability that you will inherit a certain allele pairing. Okay? Phenotype is going to be different, because now what we're going to do is we're going to take each genotype and we're going to assign it to a particular trait. So think about the way that it's physically expressed. So if we look at big T, this individual will express tallness. Okay? Is he the only individual? Nope, this guy will too. Okay, so big T, little t, the heterozygous condition will also express the dominant tall trait. So we take their percentages and we're going to add them together, and we would say there's a 75% chance of having tall offspring and a 25% chance of having short offspring. Okay? So what we've learned here is that this is the proper format for setting up your Punnett square. It's very important when you are taking a test that you show all these pieces. Give me the parental genotypes. Give me a legend here to show me what alleles you have chosen to use, a diagram of your Punnett square, and then a full explanation of the genotypes and the phenotypes. Okay, so let's clear the board. And let's just try one more. Alright, making a Punnett square. This time we're going to make a Punnett square for a homozygous dominant green-seeded male that mates with a heterozygous green-seeded female. Okay, so we have our P generation. We have our male crossed with our female. Okay, my legend over here, seed color. I'm just going to choose the letter A. Okay. When you choose your allele letters, you always want to choose letters that look very distinctive, capital and lowercase. So for example, if you would use an X and an X, that would be hard to discern the difference between a capital X and a lowercase x. So I would stick to letters that show a great difference between their capital and lowercase form. Okay, so we know that the dominant form is green. Okay, and I'm going to tell you that the recessive form is yellow. Okay, so the male's genotype, homozygous dominant, male's genotype is going to be big A, therefore he will express greenness. And the female's genotype, it says that she is heterozygous, therefore she would be big A, little a. Okay, and she is also green. So both parents are going to be green here. Okay. Next step, set up the Punnett square. So here we're going to do the cross. Okay. Gametes down the side for this parent and across the top for the other parent. Fill that in. Okay, so those are our 4 possibilities. Let's look at our possible genotypes. Okay, there are only 2 genotypes available in this cross. The offspring can either be big A, or big A, little a. So it looks like it is 2 of the 4, or 50%. That will be the double homozygous dominant, and then 2 of 4, or 50% will be heterozygous dominant. So when we look at phenotype, we need to look at each genotype and determine, will they express the dominant trait or will they express the recessive trait? So big A, definitely going to be dominant. Big A, little a will also express dominance. So here our phenotype will combine, and there's a 100% chance of green offspring, and essentially that goes without saying that there's a 0% chance of having yellow offspring. So sometimes we can use genetic crosses to determine unknown genotypes. For example, if we knew that these 2 parents were green and we didn't know what their genotypes were, if we mated them together, let's say 3,000 times, and all of the offspring came out green, we could conclude that at least one parent had to be double homozygous, because that's the only way that we would get 0% chance of yellow. Okay, so that ends the little tutorial here on setting up Punnett squares. We're going to continue practicing them in class. If you have any questions, make sure you see some of the tutorial links online.